A closed system is one that allows energy but not matter to be transferred in and out of the system. Compare that to an isolated system. An isolated system does not interact with any surroundings at all. It's completely cut off, so neither energy nor matter can be exchanged. In an isolated system, the total energy of the system remains constant throughout time. Energy can't be created nor destroyed, but energy can be transferred from one form to another. Below are some examples of isolated systems. A device called a calorimeter is one fairly easy way we can simulate an isolated system. With two nested cups, perhaps having a vacuum between them. This would ensure that the contents cannot significantly be affected by the surroundings. And it's not perfect, certainly, but it's a good approximation of an isolated system. So if we throw in some ice cubes, let's say, along with some water, then the contents will neither gain energy nor lose energy as a whole, but we can see energy transfers between them. And so what would happen here is a phenomenon called heat flow. Energy would flow from one of the participants here to the other. So which has the higher energy? Water at 50 degrees or ice at, let's say, 30 degrees? Well, it turns out, though, liquid water has more energy. And so, energy will flow from the water to the ice. It's called Q, the letter that we give to it. Heat flow. But notice that no energy actually left the system. It was just an exchange within the system. Another example of an isolated system is many consider the universe to be an isolated system, because by definition, the universe contains everything.